Let's start. So today we are going to start with the IIR filter, infinite impulse response filter. So last lab we have done finite impulse response filter. As I told you guys, this one is better than FIR, but it will be less accurate than FIR filter. FIR filter will use more order, and IIR filter will use less order on our transfer functions. And as is our last lab, we will do more, okay? We'll do a little bit more work so we can work together. So all of you try to do with me, and you need to share your screen because on during midterm, we finish our classes quickly, right? Now we are supposed to do it 6 hours class, right? Are you guys ready for today?
Yes, ready.
Very good.
Yes, Rudy, but don't take attendance, please.
No attendance for 6 hours. I should put double attendance, right? All right. Let's start then, Bismillah. So digital filters can be implemented in two ways, convolution and recursion. So recursion is the one today we are going to do. This is also called infinite impulse response filter. And this by convolution can have far better performance than filters using recursion, but execute much more slowly. So there's drawbacks of using convolution. Convolution is better than recursion, or if you can say finite impulse response is better than infinite impulse response in terms of the quality. But the problem is finite impulse response will be slower than infinite impulse response. So it's a very important question. So why it is slower? Anyone can explain? We have talked about it many times. Why it's slower than infinite impulse response, the finite impulse response. Anyone? You
It
remember?
will take more time calculation.
Yeah, more. It has more order, so it will take more time to execute. So remember on lab 10, there the order number was 20, 40, like that, right? N was 20, 40. But in impulse response, we'll see that we will have the order numbers 4, 5, like that, not much. Okay. So more order, it will have better quality of the output, but the problem will be it will be slower. Easy to remember, right? So if you look at lab 10, where is our lab 10? Lab 10 or lab 9, we have the pictures of orders, right? So the block diagram is getting higher, right? If you have more orders, the block diagram will be larger on the vertical axis, or if you want to draw in horizontal axis, whatever. So if I have more orders, it will be slow process, but it will have more accuracy. But if I have less order, it will have less accuracy, but it will be faster. Easy to remember, right? So it could be an important quiz question for multiple choice question for our exam. Okay. So again for lab 11, FIR filter, we didn't have the denominator. We don't have poles. But for infinite impulse response filter, IIR filter, we have denominator as well. So we have poles over here. Okay. So this is the important difference between the FIR and IIR. So IIR, we have no poles. All the poles are zero, located in the zero origin. But for IIR, we will have poles in different location. Okay. So number of poles equals to number of zeros for casual system. M will be greater than N. So several methods are widely used to design IIR filter, including Butterworth, Scheffler type 2 elliptic method. These designs differ for sharpness of the transition between the passband and the stopband. And we are going to use the elliptic method for us, for our design. Okay. So elliptic method has a smallest filter order for the same specification. So it will be faster to execute to get the output, and the narrowest transition width of the same filter order as compared to other filter type. So on the negative side, they have the most nonlinear phase response over their passband. So in the passband, we will have some attenuation in this elliptic filter, but it's still okay. So it's not a big difference. So for MATLAB command, so we have elliport and ellip, two built-in library function where we have to give this units, right? So these parameters we require for these two functions to get this one. So to find the number of orders of your system, we need to give WP, WS, which are the passband peak-to-peak ripple, and the stopband minimal attenuation, and RP and RS are the passband stopband edge function. And over here, when we get the poles and zeros, B and A, yeah, B are the zeros, right? Poles are the A. We need also the order number. Order number we'll get from here, this this first MATLAB command. And then we get the RP, RS, WC, and the filter type. Okay, filter type we need to tell them is it a what do you call? Is it a low pass, band pass, or stop band filter? Okay. So remember to do this one. The WP and WS are the passband peak-to-peak ripples. So over here, SP can be correspondent with the WP if you convert in DP. So we can check what is the minimum peak we got and what is the maximum. So maximum minus minimum will be the WP in decibels. And we need WS. WS will be the maximum and minimum attenuation over here as well. So stop band minimum attenuation in dB. All right. Then RP and RS corresponding to this figure, FP and FS. RP is the passband edge frequency and like when it starts, edge frequency of passband, and RS is the stop band first frequency, or you can say also edge frequencies. Someone has any question? Anyone? Okay. So over here, we are not writing over here WP and WS and RP and RS because it will have to normalize. This frequency should need to be normalized with Nyquist frequency. So FP corresponding to the RP, if you normalize with the Nyquist frequency, then FS is corresponding to the RS. And SP is corresponding to the WP and WS corresponding to the SA. Okay. So when we do the lab, then task one will be more clear. Anyway, we just continue with this one. So N is, we already know, this is the order of the filter, and WC is the cutoff frequency. And again, we need to normalize with the Nyquist frequency. And for bandpass filter, we have two, right? WC1 and WC2. So we need to put in a bracket, third bracket. We have done this one in lab 10. And also the last thing we need to say, the filter type. So filter type, we have to say low, high pass, and stop band. Okay. Any questions so far? So we need these two equations and we need these parameters for our task today. And also we need to tell the type. Everyone clear? Please someone say yes or no.
It's clear,
Yeah,
clear.
yes, clear, clear.
Thank you. Okay, let's start with the task one. Okay, so you guys also try to do it because over here we need to find the transfer function and we also need to do the block diagram. So first we will do the task and we need to get the answer for the transfer function and block diagram. So the bonus work will be coming from, so you have to draw the block diagram. Maybe you can draw it by pen and paper and take a picture and send me through the chat box. And also the transfer function, you have to do it by yourself. You can do it on in a paper or wherever you want. It's easy, right? To put it in a paper, pen and paper with the transfer function and the block diagram. So for transfer function, we need the B and A, the values of B and A, right? So we'll do this one to find the B and A, the values of B and A, the zeros and poles. For block diagram, we need to know also the number of orders. Okay, so we're gonna find with these two equations. From this equation, we'll get the number of order, and from this equation, we can get the values of poles and zeros. Everyone ready? So once we are discussing our work, so you can also write it down the, what do you call, the codes. Okay. So for task 1, it says the sampling rate will be 1000. Okay. Then we need to find the Nyquist frequency divided by 2. For WP, it says 200. And for WS, it's 300. So we are normalizing with Nyquist frequency once again to find out the values. And it says the ripple, passband ripple. Ripple means the maximum minus minimum, right? What is the ripple between maximum point and the minimum point on the passband? So it says 2. So over here, maximum and minimum, maximum minus minimum is 2 decibel. So it's given already. And RS is given also 40, stop band attenuation. So it's given over here, RS. So we got all the values required by this equation. So we need PS, WP, WS, then, okay, we should write over here WP, right? So instead of W, we can like omega, let's put WP, WS, RP and RA, we got it, right? And we also get the NRP. So we need to find the N from this equation. So first we will run this code, Heliport. Okay, let's see if we can get this one or not. I will run it. Change folder. Okay, so from here, if I click on N, I can get the number of order. So as I said, for IIR filter, the number of order will be less. So it will be not 20, 40 like that. So it will be only 4. So we got the value 4 for the, what you call, for number of order, right? Now we need to find the WC also, cutoff frequency. So just got over here, we got 0.4. Okay, we got the values over here. Now we're going to use this equation, the second equation, to find the B and A. So from there, we get the cutoff frequency and also the number of order before we know the RP, RS, WC. Okay. From here, we can say this is a low pass filter. Where I can get this information is it's a low pass filter. Anyone? It's hidden somewhere in the question. I need this information, right? What is the filter type? So over here, I put low. How I got this information? Anyone? Look at the question. Yes.
I'm not sure, but maybe from the stop frequency or cutoff frequency.
The red text, LPF.
Yeah, very good. It's over there, right? LPF, low pass filter. Is in IIR, infinite impulse response filter, and also it says low pass filter. Okay. Very good, Marshall. Thank you for trying. So it's all the information are there. You have to just dig it out. Okay. So it will make you confused during the exam. Try to not get confused. Okay. Done for this one. So we got the, for number 1, estimate the order. We already find the number of order is 4, right? Then the frequency are normalized with respect to Nyquist frequency. We done this one. Okay. The deviation are in dB is done. Okay. We have done use the number 2 also. Okay. The function to generate the coefficients of the filter. We got the coefficients, right? Now number 3 is asking for you the frequency response of the filter, both magnitude and phase. We have done this one before. So we have to just use the frequencies and the magnitude and also the phase Okay, then we need to plot these two figures until this one. Okay, so this one you guys did it right for lab 9 and lab 10. Then you have to also know the plots and poles and zeros from here. And the last one, the impulse response. Okay, from this one we can find the poles and zeros. So to determine the stability of the filter, we get the order and poles on the Z plane. Okay, and the last one, we need to find the impulse response to check is it the stable system or not. So we just got this one. I will get rid of this question marks. Over here, we have figure 1. So we just say over here it's figure 1. And then figure 2. You're doing it. Next thing you have to do the transfer function. So just get ready to send me the answer. So this one will be figure 3. This one will be figure 4. So just it's just simple of like lab 10 and lab 9, we did this one. Okay. So is the system stable or unstable? From this figure, what do you think? Anyone?
Stable.
Stable.
Yes, clearly stable, right? After 60 or 65, there's no alternation at all. So also we need to check the poles and zeros, right? So all the poles and zeros inside the unit circle. So it's a stable system. Everyone okay? Then we have the transfer function for phase. Then we have the also the magnitude. So we got the linear and also frequency response and the magnitude as phase both. Done, right? So from question 4, what is the order of the filter? Is 4. So we know the list of poles and zeros from our parameters. So over here we have the parameters B and we have the parameters A for poles and zeros. And then is the system stable? We got the answer also. The system is stable because all the poles and zeros are inside the unit circle. And also for our impulse response, we see that at the end of the line is become stable. Okay, now your task is write the transfer function and the filter block diagram. So you get the values, you run the code, and you get the values from this one. So you can run this code and find the values of B and A and give me the transfer function and the block diagram. Okay. So again, whoever get this first will get 10% bonus, the correct answer. Anyone trying? Any update? Guys, where are you?
Yeah, we are here. Just 1 second, 2 second.
No, it's take your time. All of you have to share your screen, okay? We need to see that all of you are working. So your attendance will depend on your work today, okay? Last one. Try to work together so you can also finish your work with me so you'll have no assignments later on. Today we're gonna finish all the tasks today in the class, so you can submit after the class. Can you please all of you share your screen? Okay, one second. I will check. Start this one. Okay. Can you please all of you to share your screen? I give you the option to share. So today, if you want to get the attendance, you need to share your screen. So Abdurrahman Ibrahim is sharing. Sorry, Ibrahim Mohindi is sharing. Abdurrahman is sharing. Salaman Jawa. Saad Abdullah Alazi, Naif Omar Hatim. And who is the Arabic name? I cannot read. Mubarak. You need to share your screen. So Rayman, you're done already.
Maybe.
Inshallah. Just check final. Give a final check before you submit. And just send by WhatsApp. Sorry, send by chat box or email wherever you like. Saad, can you hear me? Abdullah Lazi, can you hear me? Where's this guys? Naif? Omar Hatem? Omar? Abdullah Salaman Sanctifying. Okay. Mubarak, can you guys call them? Where have these guys gone? They started sleeping? Salaman Jawan, Ibrahim, do you need more time to complete the task? Transfer function and also the
Doctor, I couldn't do it, so I couldn't figure it out. Yeah.
you can find that answer. Don't worry. We will learn together, inshallah. Your program is not running. What do you say? You have any error while running your code?
No. No, I couldn't do anything. Tried, but I couldn't do it.
What about the transfer function? You remember you can check lab 9 to see how we did, how do we draw it, and also how did we write the transfer function. It's important for the exam, so if you can practice, now it will be very easier for you. Sulaiman Jowa, what do you think? You can do it?
Yes, I can.
Okay, I'll wait for you then.
But I need time.
Okay, take your time.
Lab 9 or lab?
Lab 9 will be easier, right? Where we did B and A. Lab 10, we didn't talk about A, right? For FIR filter, we
Yes.
just have the poles.
The backward coefficients.
So lab 9, you have how to write the transfer function. So you have the values of B and you have the values of A. So for transfer function, you can write starting from B0, P1 like that. For transfer function 1 A plus A. The first equation, the first one, you can see the B and A. So when you run the MATLAB file, on the right side, you can see the parameters, right? B and A is already there.
Yes. Mhm.
If you double click on the parameters, you can see the B and A. And also if you just put these values on the transfer function. On the right side, you can see the parameters, right? On A and B. So you just need these values to put in the equation. What we have done in lab 11 or lab 9, you can see the equation on the first page. That is H equals to B divided by 1 plus A. Okay, let's help you guys. I think Abdurrahman already sent the solution. Let's check. So the transfer functions, let's match with my one. I will share my screen. So this is another one. So nice. I already put the values. So our B, can you guys see my screen?
We need to close our share.
Yeah, maybe you can close your share, or you can double click on my name. Maybe you can see also. And there's on the top, there's an option also. You can select which one you want to see. Everyone can see my screen now.
Yes, yes.
Yes.
Okay. So from when I run this code from here, elip and eliport, I can get the values of B and A, right? So it's
Yes.
coming over here. If I double click, the value of A is 1, then 1 minus 1.6, 2.0 like this. And the B is 0.051 like that, right? So according to our equations, if I'll open the PDF, lab 9 or lab 11, wherever you want. So we have the same equation, right? For lab 11, B naught plus, for transfer function, B naught plus B1, Z minus 1, B2, Z minus 2, and the all going on. So over here, we got the B naught starting from, if we check 0.051, right? So first B was, look at the parameter, 0.0551. So B naught is 0.0551. Then B1 equals to 0.0845. Then B3 is like that, 0.122. Then the last one, B3, B4 is 0.0551. So we did the same thing over here. So our transfer function is hz 0.051 to the power z minus 1, then z minus 2, z minus 3. Okay, should be multiplication sign instead of power, right? V1 multiplication, then multiplication, or you can just leave it without anything. Last one also. Everyone clear until this one?
Yes, clear.
Okay. So now let's check with the A, the values of A. If I double click again, double A. So first one was 1. By default, it's 1, right? 1 plus A, 1Z. Second one is minus 1.69. Third one is positive. Fourth one is negative. Fifth one is again positive. So we also put the same order, 1 minus first one, second one, third one, and fourth one. This one also should be multiplication sign. Everyone clear so far? Easy. So once we get the value, we can make the transfer function, right? Is it hard or easy? Anyone? Yes or no? Someone send me a chat message. Easy. Otherwise, easy for you. Already done it. All right. So we just check his values, minus 1.6 plus 1 minus plus 0.4. Mashallah, you did good. So you got the sign. And now when we draw this one, if I look at the PDF once again, is it 9? I have 9, right? So in PDF on 9, we did the same thing, right? Just put this value z minus 1, z minus 2, or instead of b naught, we will put the value of our findings, the parameters we got. Okay, then we put the summations and we get the feedback once again, like this way, right? So one thing he did, the one, it is, this one is 1 plus, right? This multiplied with 1 is everything same. So in according to our equation, it was 1 plus a1 z minus 1, a2 z minus 2, like this. So first one, you remember we got the negative value, but when we draw this one, we have to put negative for this one as it to show that it's a feedback. Okay. But when we try to put the transfer function, we'll put plus values. But when we draw the block diagram, we need to put negative values to show this is a feedback values. So as by default, we put minus sign. If the value over here, if the value is minus, okay, then it will become plus. So over here, we got the value minus. So he put plus 1.6935. Then since I got this one value 2, something 2.01, I put minus 2.01. Then again, this one was minus 1.2, it would be plus. And this one will be plus, it was before plus 0.46, it will become minus 0.46. Everyone clear? Very good, mashallah, Abdurrahman. I'm so proud of you. Any question how to do the block diagram? Please practice this one, very important, okay? For your exam.
Yeah, we need to practice because for me it's not clear.
Now it's clear now?
Not 100%, but it will be inshallah.
Did I explain you again?
If you can.
Yeah, sure, why not? My job, we need to make halal, right? Okay, so first thing, just you have to remember these two equations, okay? But this is difference equation. This is our transfer function.
Yes, okay.
Transfer function, this by default, you have to remember somehow, or in the exam, you can bring 2 A4 paper. Before they said 1 A4 paper. Now today is a change for 2 A4 papers. Maybe before exam, maybe 3, 4 papers could be done.
Okay, maybe it will be open book.
Yeah, could be. They keep changing, don't worry. So at least until so far we got 2 pages, A4 paper. You can bring these 2 equations, okay?
Mhm.
Or if you want, you can just print out and put some comments on that one. So you can use your papers wherever you want, whatever you want to write it down. So this transfer function you need to remember, okay? So for transfer function, all are positive, right? So whenever we run the MATLAB file, we get the B values and A values. Right? So we need to just put these values over here. Z minus 1 will remain same. Okay. This is to show the number of orders.
Hmm.
So until B to the power 4 or B to the power 3, it will go on. This one is easy, right? For transfer function.
Yes, easy. This one is easy.
Only problem with the block diagram, right? Sometimes I
Yeah,
am
yeah.
confused with this one. So this one, if you look at the transfer function, all are positive. Yeah. But when we draw the block diagram to show that this A's are feedback, okay, this is feed forward, right? B0, B1, all the zeros are feed forward, and all the poles are feedback. So we need to put minus sign. So over here, if I have plus, all the plus, it will be all minus sign for the block diagram. This part is clear for you?
Yes, yes, clear.
Okay. Now, when we run the MATLAB file, if I have values B positive or negative, I will just directly put positive or negative, right? If this one was minus 0.0551, I will put directly over here minus
Minus.
0.051, right?
Hmm.
This one positive, I will put positive. But for feedback one, the poles, it will be
Be
opposite.
the opposite.
Yeah. So if I check my A values of A, okay, 1 will be okay. There's no problem because anything multiplied with 1 equals to yn, right?
Yes.
So there's no issues with 1. But for A1, I got this value as minus 1.69. So whenever I put in this area, minus multiplied with minus become plus, isn't it?
Yes, yes.
Same thing for over here, 2.01 multiplied with minus will be minus 2.01. And over here, minus 1.2 multiplied with another minus will be plus 1.2289. That's what Sulaiman did as well. If you look at Sulaiman work, first one become positive because minus multiplied with minus is positive, right? Second one multiplied with minus will be minus 2.01 because over here no minus. Is it okay now?
Yes, okay. Okay.
Okay. You need to go through again.
Up to you.
No, I will wait until you say yes. Okay. Then I will go forward. I need everyone to understand. This is very critical part. Maybe in the exam, you have to like come down first while you do this one. Okay. Sometimes I also get confused. Okay, it's not that easy to remember this figure. Try to remember this figure over here. So this side will be all plus, this side will be all minus. If I get the value minus, it will become plus, right? Minus multiplied by minus. If I get a positive value of A1, it will be minus positive value. If I get again negative value, it will be negative minus negative, negative multiplied with negative, it will be a positive value. What do you think now? You have to remember this equation and this one. I think for exam, it's better you write this equation on the paper and also draw this block diagram. So you can remember this one will be positive and feedback will be negative. Okay, the poles will be negative and zeros will be positive in the block diagram only. Okay.
It's clear.
Okay, mashallah. Thank you. Okay, let's go back to our 11, task 1. So we have done our part until number 4, 5, 6 done, right? Now number 7. Okay, first let me give him the bonus. It's Abdurrahman Sulaiman. First one, right? Abdurrahman Sulaiman. Okay, so we're here. 60 highest. Okay, mashallah, 60 bonus point. Now we need to do number 7. Use the Kaiser order estimation MATLAB function. So Kaiser to calculate the order of the filter with same settings. What is the order of the filter with same requirements? Let's see if I use a Kaiser then before we use Eliport, now I use Kaiser. Let's check our code. So if you put help for Kaiser, okay, then you can check I need some elements over here. So I just put help Kaiser CRORD. So again, it's a MATLAB command done for us to design filter. Okay. So over here, we need to put some values. So if I look over the help option, so we need to give the filter type, number of order, and we have to also Kaiser NY1 and NB. So if you look simpler equation over here, so we can get the number of order. We use small n, so I will not confuse with the big capital N. Both are order. Over here, if you look at our parameter, capital N was the order we found, use the Eliport, right? And if I use the Kaiser order, I can use small n to just differentiate. Okay, you can also put capital N1 over here. So we need 4 things to information to find out the Kaiser information. So we can get number of order, we can get WN, VTA, filter type, okay, and we need to give them 2 frequencies. We have 200 and 300. Stop and attenuation. We have to give them the information 1 and 0. We have to also give the sample frequency. So look at our work over here. So first thing we need to know what are the parameters we need. So over here we need Fn WPS WS multiplied with and 1 and 0 for the maximum value of 1 and 0 over here, and WPS and W is wanted here to be in the horizontal one, right? So we can get these values over RP minus RS, the differentiation, and the sample rate was given before. And we need to also write the cell as a code. So for normalize just go to help and it will help in writing it. Okay. So just we make sure we get this one right. Control T. So we need to find these 3 values, right, over here. So we can just go Kaiser on over here, log 1. Okay. We are getting these 4 values. I want to get this one copy. one over here. So we need these values to put RP minus RS just there. We have already RP and RS found out 2 and 40. Okay. Then we need WP and WS. Fn is divided also found out over here. Fn is there, WP and WS is here. Okay. And then Fs is there. And also we have Fs is 1000, right? We have sample frequencies declared over here 1000. And we need to also write cell for this code to show what is there. So if I run this code, low pass filter will be there and binary. We just look over here. Okay. Now look at C. We'll get C, right? So C will give you all the information. So number of order will be 23. 0.5 will be the one. The filter will be low type and it will be non-scalable. Okay. So we'll get 24 values for this one. So just I'll copy in over here with what will mean by C. Okay. C will give all the values over here. BTA, file type, all the information. I can just put this one comment. Okay. So instead of putting the value, I can use it directly, WP, WS. So I can easily get this information. So I don't need this one. So I can put this one as C. So we will get 4 information from the C values. So once again, I check. And also non-scale is not important. We got cells. Number of order will be 23 this time. And before we had the number of order was 4, right? Number of order was 4. This time we can get the number of order 23. So if I use Kaiserod, I will get more accurate value, but I will get the higher number of orders. Everyone okay? So this is one line code because we already have all the information over here. Clear?
Yes.
Okay. Now let's go to task 2. Task 2 says typical phone lines. What we normally do is like if you can hear me over phone, it's different than real person, right? When we talk face to face, or if we talk with you in a digital studio or in the TV, my voice is better than telephone calls, right? Why we do this one? Because it's not very important when we talk with you. Normally, I will not sing for you, right? I will not sing a song or very. I don't want to be. It's not that important. Your voice should be very nice and it should be have a what do you call very smoothing sound, right? So when we send the signals through a phone over phone, we want to minimize the bandwidth. So we have to pay less to the government also. So over here, Ooredoo and Vodafone is paying for the bandwidth. Okay. Same thing, the radio stations, they're paying for the bandwidth. Okay. TV station, they're also paying for the bandwidth. So if I get less bandwidth, if I can send the same signal with less bandwidth, I can save some money. All right. That's why the telephone companies, they buy less bandwidth to transmit the signals, since it's not that important for them to get the better quality. So same thing we will do over here. So just check if I sending a signal, the real one. So over here it says we have to get the signal high wave we have done before. So let's see our task 2. Okay. So we can get all the information over here. High wave is the file we're gonna read. So if I play this one outside of our system, open outside MATLAB.
Hi, name is Meet, and I'm going to show you how data types work in LabVIEW. In LabVIEW, every object in wire is always associated with some data type.
Okay, so it's very nice and clear, right? So let's see with RP 0.1, we got the values, and F2 and F3, edges 0.9 and 0.9, and F4 and F1 and F4, including our picture over here. We need this all information. So this is our passband. I will send all my signals through this area. So I will delete all the information on the stop band. I will also delete all the information on the high pass area. So this is our passband. I need this one F1, F2, F3, F4. Okay. So according to our information, I got F2 and F3. Our passband edge frequencies. Okay. And also F1 and F4, the stop band edge frequencies. All are given. And also stop band attenuation is given 20 decibel. Passband ripple is given as 0.1 decibel. So over here, the passband ripples are 0.1. And over here, the stop band attenuation is 20 decibel. This is done. So this is our original file. Now we will send this signal through maybe in bandwidth, some like with our antenna, and I will receive from other end. Okay. So let's see how it, if I put this filter, how it's gonna sound. So again, we're gonna import, we'll get the number of order, we'll get the values of B and A. It's not required for our question, but we'll do it to know what's going on over here. Okay. Then we're gonna use the filter to play the sound. Okay. Let's play the sounds now after I run this one.
In LabVIEW, every object in wire is always associated with some data type.
You guys get it? How we send the signals on the over phone? Anyone? Is it clear or tough one? Can you guys hear me?
Yeah, I hear that.
Okay. So you heard that sound, right? After we send it to, if I use a filter to minimize the bandwidth, how it sounds.
Yes.
Okay. We can still understand it, but the quality will be not good. Okay. This is what the people do in Ooredoo and Vodafone. They do these things when they send the signals whenever we talk. Everyone clear? Any question or task 2? Yes or
Yes,
no?
clear.
Okay. So let's go to task 3 for notch filter. Okay. So what we are going to do, we have before ECG text file, right? We got someone's ECG report, and we had this file ECG text once before. So we'll check this one with the noise, if I have the signal, and after I filter it with the notch filter, how it looks like. Okay. So if we go to our task 3, so first we need to load this file ECG. We have to download all the files, right? ECG and also the high wave from our Google Classroom. First, we need to load the ECG text in a variable called X or whatever you want to put your name or something. And then the sample rate is not given here. Okay. So by default, we just use 1000. If you want, you can put 10,100, whatever you like. So over here, we put 100. This depends on you, how many samples you want. Okay. Then we're going to interpret the sampling increase the rate. Okay, of the of the ECG text we have. Okay, and we can also increase the sample rate with multiplied with 3. So we get same number of values. So first, if I check the X without this one. Maybe I can put this one x1 and fs1 instead of this thing. Just put this one all in the comment. Let's run this one first. So first we have sample 100, okay, and then we multiply with 3. It should be 300 samples. And same for the ECG, we had the values 6,000. When I multiply with 3, we will have 18,000. 6,000 multiplied by 3, 3 6 are 18, right? 18,000 values we will get from this information. We just multiply to make it see better values on the our spectrum on the linear scale. So just get back to, I will put all fs1 or x1. It's better, I think you just remove fx1, x1. So you guys understand the similarities. We just updated it. Fs, yeah. So last one will be x1, right? Yeah. So we just replace x with the multiplied with 3 and also replace the fs multiplying with 3. So we will have more samples and more data for the x values. Okay. Now we need to find the length of the x we have done before on lab 6. Okay. For to read the ECG text. Then we need to find the period. Then again use the linear space to plot the x-axis. And we get the noise 0.1 sine 2 pi to add the noise on the system. Okay. First, when we transport the noise over here, so x and noise are opposite. One is row vector and one is column vector, right? So we need to transport this one. So if I look at the noise first, if I run this code once again, this one. So the noise, variable noise, was in horizontal, right? So all the axis in the x-axis. And then if I look at the x, it was vertically. So just look at the x we have, it was vertical. So to match this one with multiplication, we need to transpose it, right? We need to put it vertically as well. So that's why we use noise transpose over here. You guys clear with this one? We create the
Yes,
noise,
yes.
we create the noise and transpose the noise to match the vector. Okay. So noise are opposite on one row vector and column vector. So we made all of both of them column vector so we can add. Otherwise it will give us an error because this one will be column vector and this one will be row vector if I don't do the transpose. Okay, that's why we did this one. Everyone okay?
Yeah.
Now if I plot the x, let's see what is going on over here. Just put this one percentage and then we just open this one, Control T, Control R. Let's run it. This is our ECG text with the noise. All right. Now, if I want to put the filter to get the clear option, so it's, the shapes are not good, right? And increase the sampling rate to the ECG, adding 2 points in middle. So if I just make zoom in, maybe in the place of 6,000. Okay, and we can zoom in more. See, we have many disturbances over here. So many ripples on this area. Okay. Let's see if I use the filter, what's going on. So design a 50 Hz notch filter, and I will try to get this one over here. So we're gonna design the notch filter. I need another one, right? We'll design the notch filter. All right. So this one, right? And again, we use the function Nyquist theorem, Fn. to divide it to normalize the frequency. Okay. We will find the values of poles and zeros with this code IR notch. Okay. You need to give the information of F naught and also BW over here, and filters of the ECG needs to be commented. Okay. So we put the filter for the ECG text, and then we plot the figures of without the filter and with the filter. Okay, so this one will be without the with the filter, and with other one will be. And leave this one over here as a drawer. Thank you. So figure 1 is without the filter, and figure 2 is without with the filter. Okay, let's run this one. Look at these figures. Even without zooming in, I can see there is more noises. And with this one, after we use a filter, it has less noises, right? So again, zoom into these two parts, maybe 6,000 area. I'll just get over here. For this one also around 6,000 area, and we'll just zoom in. What do you think? Which one is better?
The filtered one.
Filtered one, right? So the noises are gone from our ECG text. Clear? So if you use this IR notch code for the MATLAB library file to remove the noises from the text file or ECG file we have, or any signal you want. Even clear?
Yes.
So this is our end of task 3, and we have nothing more. So if you do it with me, so you can submit now your work, or you can take more time. So I have given it until Saturday. So our exam will be on Sunday and Monday, right? You guys already got the schedule for exam?
Which schedule?
For exam, not yet.
For which exam? The lab or the lecture?
The lab.
No, I didn't see it. Did you send it?
I think they will send you. So they may change again. Okay, so I will just show you what I got. So it's maybe not 100%, like, they can change anytime. So your exam will be starting what time? 3:30 p.m. on 11. Okay, so next week, Sunday, is your exam.
Oh, next week, huh? Okay.
Yeah, for lab exam. So as far as we know, we can bring 2 paper of A4, both sides you can write as much as you want. Okay.
Double face?
Sorry?
2 papers with double face?
Yeah, both sides. As much as you want, okay? So this one will be, and Sunday, inshallah, see you guys on the lab. BCR E200 202 3:30 p.m. Okay. All right, guys.
Thank you.
Thank you once again, and thank you for your patience with me. Inshallah, see you on the lab. Please let me know if you need any help. Okay. Someone sent me a message. Thanks. Okay. No question, right? Thank you, guys. You guys are really proactive in the lab. I'm so happy with you guys. Okay. Let me just take the attendance, and I will let you go. So who is not present and who is present? Once who is present under me. Abdurrahman, Nashat, and Salman is present. Our best guy we have done. Saad Khamis is present. Abdullah Muhammad Alazi, still sleeping? Is he? in the chat box. Sally is here. Abdullah Muhammad Alazi, I saw him. Yeah, he's here. But I think no response. And Muhammad Hamad Al Mariki, absent. Then Muhammad Abdullah Al Manani, absent. Sulaiman is present. Yes. Ibrahim is present. Then Omar is present. Naif is there. Omar,
Okay, doctor.
okay. Omar is also here. Okay, thank you guys. All the best wishes for the exam. Okay. Please let me know if you have any questions. Okay.
Thank you, doctor. See you next week, inshallah.
Thank you, everyone. Have a good night.
Assalamu alaikum.